Alright, welcome to Computer Science 305. This is the solution video for the Ruby lab. So, we'll start with first acquiring the actual lab. And we'll do that by cloning the Git repository. So this will take just a few seconds here. Hopefully not a whole minute. And once we have this, then we'll start writing the code. Alright, so we have the Git we have the actual repository. So we'll go ahead and open that up. Okay, so go ahead and see if I can't do this. That way we can actually see what's going on. Okay, so if we recall, we have a bunch of code in here. I'll make a few minor changes to mine just to get it up and running. I found a better way of handling the operating system check. So I'm going to add that in there really quick. Alright. We need to require one last piece. This was... Okay, of course, as we always do things, we have to update our comments really quickly. So we will do that. All right, everything's good to go now. So we've done step one, -1. We forked and cloned the repository. Now we're going to get everything ready, right? So I've already done all that part. We can validate, just make sure. I'm inside Atom, and we can say bundler-v. We have it installed, and we say bundler, or say rspec, and verify that it's also installed. Okay, we're good. Okay. So we know we have a data set, it's all good. I'm not going to walk through all that stuff. So the first thing we need to do is extract the song title, right? So it says we need to create a method called cleanup title. So we'll go and do that. Takes a line. Okay, so... we know that we have to first find the actual piece, which is everything happens to me. So we know that we don't want all this. So we're looking for start. So first thing we want to do, let's say we have, we'll create a variable title, set equal to line for now. And we'll say title.gsub. Or sorry, that's sub. And the regular expression that we want to match here, we're going to replace with nothing, is start needs to start at the beginning of the string. So we use the caret, and then it will match until the last instance of the greater than symbol, and we're going to match anything in between. You can do the dot star or dot plus. This will be greedy, and we'll try to match the greatest, the largest possible match you can make. So that would be this entire piece right here. If we put a question mark after the plus or after a star, that will try to match the smallest version, which will only match this piece. And so that's not what we want. Once we've done this, we can then move on to the next piece, right? So then this next part is we need to remove the superfluous text, right? So tells us that we're going to have look for any of these characters here, or the word feet followed by a period. So then we have to say, all right, oh good lord. So we'll go ahead and do that. And we're going to substitute again with the empty string. So now we need to find we're going to look for some character class. Actually, we know that we need to go to the end of the string, right? And so we know that we have to have at least feet followed by the period, right? And so we need to make sure that we use the dot. We need to escape the dot because that normally would match any character. And then so we need, after this class or this group that we're building, we know that there's going to be just any other characters. So we'll use the dot star. So then, once we have that good to go, we will go ahead and also have to capture a character class that we're going to create, which will be the open parenthesis, the open square bracket, the curly brace, the open curly brace, the backslash, as well as the forward slash, the underscore, and the hyphen, the colon, the open double quote, the backtick, the plus, and the equals, and the star, right? Which actually I believe we can just do plus, equals, and star. So we will need to also, just in case, do that. Okay, so this essentially has captured everything that we need so far. So let's go ahead and comment that just to make it nice and clean. We'll call this remove, we'll say this superfluous text. And this one above was, we'll trim everything up to the beginning of the title. Okay. So then, we followed all that. Now we need to eliminate any punctuation, right? So in this case, we're not trying to remove just everything following or everything before. We actually need to remove these items and do it in every possible scenario where it will be captured. There's something going on here. Trying to figure out why it's doing what it just did. Okay, so we'll come back to why it's doing what it did in a bit here. The next piece is we need to eliminate punctuation, as I just said. So eliminate. And so we're going to do the same thing, but instead of using dot sub, we'll use gsub, right? And then we need to capture, and we're going to create a class. And so how I did that when I was doing it was I just literally did a copy, pasted it, and then cleaned up the text. Okay. So then we need to, once we have that, we'll end the regular expression and replace it with nothing. Okay, so we've done that. now that we've gone through, we've cleaned this entire thing up, apparently, we need to be sure to return the title. All right. Actually, we don't even need to do that. That last line will evaluate and will give us what we care about. So now we know that when we clean the title, so this method cleans title and returns cleans and returns the title. Could return nil. All right. So now we go and look here, and we have to filter out non-English characters, right? So we need to ignore anything that has umlauts and all sorts of other golements and etc. That's not part of what we want. So it says here that it may be easier to match tiles that contain only English characters than to match tiles that contain non-English characters. So I define English characters to include the meta character definition /W/S in most languages, as well as the apostrophe character. Probably should also include decimal digits, just in case. So let's go through and we'll handle that. So we come down here. We actually probably should call that previous thing that we actually made, right? So for this, since we have I have two different approaches here. If you were doing this, you could just do it right here yourself. I'm going to create a new component called new method called process line, which takes line, because we don't want we want to follow the standard principle of don't repeat yourself. In other words, avoid duplication of code. Okay, so in this process line, basically we're going to take the line and we're going to create. I'm going to call it title equals clean title line. So that should work, right? And then now we have to do this non-English character stuff. So we say if, so we say unless. Yeah, I'm just going to do if. If not, title dot nil, right? Because it could be nil. So if it's not nil and it matches, so we say song matches, and then we need a regular expression for the non-English characters. So we have to start at the very beginning of the song and go to the very end, or of the title, and go to the very end of the title. And so we can create a character class which matches what we just talked about, which is /W/S/D, the apostrophe character, and that's it, right? And so then we say plus, right? We need to have, it needs to be made up, the title needs to be made up of one or more of those characters from the beginning of the title to the very end of the title. Thus, it's only composed of these characters. So now that we have that built, okay. So we'll end that. So that gives us step 4. And step 5 is we need to set to lowercase, right? So we need to say title.downcase. Okay, good times. So there's a self-check. We run the 8-tracks data set. After filtering all steps, I found that there were 52,760 valid song titles. We go ahead and run this. We should see that we get that. So let's go ahead and try that out. Never know, maybe I made a mistake while writing code. So we run it and we say rspec spec selfcheck 1. And I had a failure. That's no good. Maybe we should find out why that is. thinking it has something to do with this. Let's see if that change made any difference. Nope. Nope. And there we go. All right, that was my bad. Yes, gsub actually did not return what I wanted to. All right, so we're back in business here. All right. So as we can see here, made a couple mistakes. No big deal. Moving forward. Okay. So the next piece, right? We did the self-check, passed, moving along, and now we're going to work on the bigram counts. So bigram is a sequence of two adjacent words in text. All right. So we need to build up a song title, right? So we note that you provide a variable called $bigrams that's provided in the code, which will be used by the underlying self-check specification test to work. So if I was you, I would have gone in and looked at the self-check that we need to see, and we go down here and we look. Oh, there's bigrams, right? So we see that we know it's a hash already, because if we go back and look in our lab, at the very top here, it says it's a hash, right? Hash.new. All right. So we all also know that we access hashes with a key, right? Typically a string or a symbol. And then we look at this and we see that so this gives we know that we have 3 pieces of data that we're going to be storing here, right? We will have the 2 words that form the bigram plus a count associated with that, and that count is basically telling us, which it says right here, is the count of the number of times a word follows another word. So you get the first word, which is the key to the to the bigrams here, like love, and then we want, if I put love and then song as the second key, I find out that the count of the number of times song followed love through the entire A tracks is 33 times. Well, the interesting thing is, and that we also find that there are 80 words that follow love. That's what this first one is telling us. So what we might want to think about is, well, what is this actually telling us? Well, this tells us that I was intending you to use a hash. And what is the reason for that? Well, essentially, we have 1 million lines that we have to process, and we have a significant amount of individual pairs of data, right? But what's really going to happen is, if we look at this next piece, building a song title, right, we have to create a function called most common word. So what most common word is going to do is it takes one argument, the word, and we need to find the word that most often follows that word in the data set. So that means we will not have both words. We have to find the second word based on the counts. So, interesting enough, if we take a look at love, right, there's only 80 items that follow it. So that can be easily walked through, searching for the most common item, looking at every single individual word. But it's more difficult to go and build this thing up if we have a million items. We have to consistently go back in and look things up over and over. If I have to go and do an order and search every single time, that's going to take forever. Whereas if I used a hash, which is what we have, containing a second hash, so the first key keys to another hash, which then has a key made up of the second word, and then the data that inner hash holds is the count, right? So that's order one lookup for the first word, order one lookup for the second word to find the count that I then update, right? I have to do that n number of pair times for almost a million lines in the unique tracks. That will become a great time saver for you. If you chose to do it a different way, that's not going to be very efficient. And so the optimal efficient way to do this is essentially a hash of a hash, without building a special data structure that can handle this, using the built-in data structures. So we go back to the Ruby lab, which apparently I need to update my name here. Okay, so we go into this, knowing that we need to create these bigrams, right? So we know that we have to do this, so I'm going to create a new method. I'll call it update bigrams. Or just update counts. Let's call it counts. And so this takes in basically it's a array of the line, right? So we'll just call this line array. And then we also know that we need to create a method called MCW, which returns the most common word, and we'll just define that, which takes in a single word. Okay. So we are given this line array, so we have to actually create that. So that's really easy to do, right? We go ahead and we need to split the line, the title up. So we say title.split, and we want to split on spacing, right? Pretty simple. And then we want to call use this information, right? So we will then call update counts on that split array, right? We do this in our line processing outside of cleaning the title. We clean the title up here, we deal with the bigrams down here, and this checks whether or not the title is valid. So there's three different things going on. We clean the title, we check if it's valid, we update the bigrams after we downcase, right? Why did we do the downcase in between? Well, that'll come into play in a bit here. But it also normalizes. Shifting a string to lowercase is a method for normalizing the string. So now we're going to update these bigrams, right? So essentially we have to. There's lots of ways to do this. A way that a significant number of people were handling it was using the each cons. So each cons is a method of string, or actually of string, yeah, that will take a string and break it into an array, which actually I probably should do up here, but we can take an array and we can actually say each cons, which will then split it into. We'll take that array and any pair and make pairs out of it. So the first item in the array will be by its will not be repeated, nor will the last item in the array, but the inner part, each item will be doubled up. And so what we can say is we say line array dot each cons 2, right? So that's the number of inner item number of times we want to repeat the inner items. And then we will call that for each one of these items, we'll call it a pair. So what's actually going to do is it's going to set this up so that it paired out the array. I have to actually go take a look at that and see how I actually did this. So once we have that, so now that produces a pairing, right, for each of the different items. So we already have a bigram pair set up. So then what we can do is we have to walk through and check this out. So the first thing I want to do is I want, from the pair, I want key 1 and key 2 equals a pair. And so that should give me the ability to set them up as a to do parallel assignment from the array. Then I will I need to update. I need to check if the bigrams. So the first thing I want to do is I want to find out, have we ever seen the first key, right? So we can ask the bigrams, which is a hash, if it has the key. If it has key 1. If it does, then we will process that accordingly. Else, we're going to need to, if we've never seen that key, we know it's not possible that it has key 2 as well. So we just have to add in everything that needs. So we say counts. Actually, we don't have to deal with that. We can say bigrams, $bigrams, at key 1, key 1, equals the hash, right, of key 2, pointing to 1. And that's all we need, right? We have nothing else to do there, and we can end that if structure. Now, if we have seen it, it gets into a little bit more complicated logic, but essentially, we can, we have to ask ourselves, we have to extract out the initial hash, right? So we'll say counts equals $bigrams key 1, right? So this is the inner hash. Counts is the inner hash, and we ask ourselves, well, have we ever seen the second word in association with the first word? So does counts have the key 2? And if it does, then we just are going to update. So we say, actually, we could do this a slightly more interesting way. We'll work on that. I'm trying to think of a more interesting way of doing this. So we can say, no, I'm just going to do the if structure. It's a little bit easier. There is a trickier way of doing it, and I'm not going to do that. I'm going to do a more straightforward approach. So if we've seen it, then we just add 1. Else, we say counts key 2 equals 1. There is a parallel assignment approach for this. But let's not, actually we could do this. Let's do that there is a parallel assignment way of doing this. So we can say, an optional assignment way of doing this. So we say, no, it's just not worth it. This is easy, it'll work, and then we just end that. And I'm trying to get rid of it because I don't like the way it looks. It's very non-Ruby-esque. It's very Java-esque way of looking at things. But anyway, so we have that done. So we've call update counts. It works great. All right. So then we need to get this most common word stuff going on in order to pass the self-check, right? So basically we have to say in here, we just need to look up if the bigrams that has key, and we're looking at word, right? So if it does, then we're good. If it doesn't, then we just we'll have a small problem. So now we have to search through. If it has this, then we have to search through looking for what is the one, item with the largest number, right? So max equals 0. This is basic linear search. We start from one side, go to the end, looking for the item with the largest one. Well, the interesting problem here is that you might actually have a time when you have more than one item, right, that has that max value. And our suggestion is that we randomly will return an item of that size. So from that, right? So we can just say we need to have a list of those keys that we found so far. So once we have that, we say bigrams word dot each, right? We use an iterator on the hash, which returns two values, a key and a value, right? So our key and count, right? The things that we care about. We'll end that. And so if the count is greater than max, then, oh, hello, let's not do that. Then we'll say keys equals key, right? Because we found a new one, so we have to update the key again. So that resets the list to be whatever we're looking at, and then we say max equals count. Okay, that was pretty simple. Else, so we actually say else if count is equal to max, right? This handles when we see that we have duplicates, or duplicate count, words with duplicate counts. Then what we want to say is keys, and we're going to left shift or append to that the key that we found. And then otherwise, we don't care. So then, that's all good. We've handled that. So then we found, assuming that we get all the way through that, we have found all the keys with the max value. And what we need to do with that is we actually have to randomly select. So we say if keys dot length is greater than 1. We return keys random dot rand on the key length. You can actually call shuffle and just take the top one. Your choice. Actually, I think we'll do it that way. Just because. We'll say keys dot shuffle, and then we'll take 0. That should probably work. We say else return keys 0. Now, in the case that we did not reach this, right? In the case that we don't have a word, it's not one of the keys, so we can add that in. So we'll do the else. We need to end this. Else, we will just return the empty string. So we've managed to get the most common word stuff done. Now we just have to go through and start building, a song title. So before we do that, we'll run the self check for this, which is self check number 2. Say rspec. Verify that we got everything done, and apparently it can no longer open the file. Oh yes, I need to fix that so it actually tells me why it can no longer open the file, because it's actually wrong. Pound dollar. Alright. So the actual, oh yes, I meant cleanup title. Apparently I did not type that correctly. And process line, whatever that is. There it is. There we go. Okay, and variable or song. There we go. One last time. All right. Okay, so I have a bunch of failed examples. 4 failures. $79. Let's see what we get here. Undefined method of lang for song array. Okay. Yes, I meant length. There we go. Length. All right, let's try that. All right, 5 examples, 1 failure. That was a 79. I'm not going to try to fix it to get 80. I know you can. I'm just not going to go for it right now. So let's not worry about that. Could actually be just, it's 79. So let's not worry about it. And we'll move on. As it says, if you only get 79 and it says fails, don't worry too much about it. So, continuing to build a song, we need to have a create title method. So, I built that right above MCW. Create title, and that takes in an individual word as the starting parameter. So we'll say start, we'll just call it word. And that, excuse me. Now, the whole point of this is that we essentially need to walk through using the start word and build this title up. And now we are limited, right? So we want to continue until a word does not have a successive word in the data set or the count of words in your title reaches 20. So we start this out with count. Let's say it equals 1, right? Because we already have 1 word, right? So we say next, then I create a variable next word, and I want to say that's plus equal to, is equal to the start word or word. And then I'm going to say title equals the empty string for now. And so what we're going to do is we'll say while our count is less than or equal to 20, or we can just say until count is equal to 20. And then we say title plus equals next word plus a space, right? And actually, yeah, we'll do that. And then we say next word equals MCW on next word, right? So that finds, so we use our start word, right? So it's like a do while, and then we will say count plus equals 1 in the loop, and we'll return the title. We'll chomp off that last space, right? So we say title.chomp that extra space. Okay, so we look at that, and then we come down here and we have our first set of lab questions that we actually need to run. I'm not going to store them as a output, so we can actually see what happens. So we say rspec lab questions. This is 1 through 5. And now it's going to run. It'll take a little bit of time. All right. Came back, 5 examples, 0 failures. Excellent. Looks good. So now that we have that, we can move along. So now we have to enter some, we need to have user control, right? So the whole point of this is it needs to add a loop that repeatedly queries and says enter queue to quit, right? So we will go down and add that in. So that belongs, right, way down in the main, right, our get user input section. So we can add that by simply saying, we have a word, right? So we say word equals the empty string, and until our word equal EQL q do the following. And so what we'll say is we want to put an empty string, then we'll say print enter a word enter Q to quit, and maybe a colon and a space. And so then we take in a new word, standard in, dot gets, dot chomp, right? So we can get the line, and then we chomp off any extra spaces or the new line character from pressing return. And then we put the empty line. And now we need to put, and we're going to create the title, right? Because we want to put the title to the show the users. We say create title word, and then unless the word is equal to Q. All right. Let me go ahead and we'll run this. And we'll run it just to validate that we did this. So we'll say we'll go ahead and run it and say Ruby Lab. Ruby Lab, and we'll just do the 8 tracks just to validate that the input works. Oh, we have a small problem. It says require command not found. That's not good. Let's try this one more time without that. Okay, there we go. And it says enter a, we'll say I don't know, happy now the world, blah blah blah. All right, looks good. And we'll try computer just to be sure. And it comes back with, okay, looks good so far, right? And maybe we'll try sad. Okay, so we do that, and we press Q to quit, and it works. All right. So then we'll run this next self-check, rspec self-check 3. And we get 3 failed examples. That's no good. So we have to ask ourselves why. Oh, we have a whole bunch of extra junk in there. Okay, so we need to probably go in here and clean up our extra stuff. So why don't we go and go up to is it create title? Actually, let's make sure it's just that. And we're off by 1 in the self-check. I remember that being a problem for everyone. So I'm gonna go fix that. So okay, so apparently I'm doing 21, not 20. So let's go ahead and fix that. Into where is this? Oh, there it is. And we'll actually say say while count is less than 20. And we'll run that, see what happens. Still not fixing the problem. Let's go ahead and open this up so I can actually see. Oh, let's try that. There we go. Okay, 3 examples, 1 failure, and then this one I need to trim. So in the case of these words, it's probably a wise choice to strip them a little bit just to verify. Where is create title? Let's get rid of, instead of having, we'll say dot strip. Let's see if that helps. All right, there we go. So we managed to clean that up. Instead of using chomp, we use strip. That got rid of that last little extra business on there. Okay. So we passed that self-check, and now we go into the next piece, which is stop words, right? So now we have to go in and remove all these extra bits and pieces here, so that our stop words. So one of the problems, so in natural language processing, stop words are common words that are often filtered out, right? Such as common function words and articles. So as it says here, literally before taking your bigram counts, filter out the following common stop words. So that means we have to go up here and into that process line section. If I can find it again. And so it says before we do the bigram counts, right? We need to get rid of these things. So we do it right here, right? Say remove stop words. So let's create a new function or a new method. We'll call it def remove stop words. Okay. This is pretty simple. So we just a gsub. We say title.gsub. Actually, and then we'll return title. And now we're looking for any of the following: a, or an, or and, or by, or for, or from, or in, or of, on, or, out, the, to, with. Right? And we'll replace those with nothing. Okay, now if we see that, this is not going to work though, right? Because that'll find any a or an or any of these that could be existing in any other words. So we need to actually adjust it and ensure that it looks at the boundary, right? So put a word boundary on the front and a word boundary on the end. And then we're going to gsub and it should work just fine. Okay, good times. So that will handle that and we don't have to worry about them. Once we've done that, we can, we've removed the stop words. Now, there's a possibility that, I know that should work just fine. So now we've gotten that done. We can go through and execute the next lab question, which is 11 through 13. Take a minute here. And we get 3 examples, 0 failures. Perfect. Good to go. All right, the last step. So, if we were to run this, right? And say we just put in love. We note that we get love you ready, love you ready, love you ready, love you ready, on and on and on until we hit the 20-word mark. And so what it says here is there's this this should be a problematic, this is a problematic phenomenon, right? We're getting the same, we're repeating over and over. So our goal will be to figure out a way to stop this from occurring as a part of number 14, right? That's the whole thing, is we want to stop this repeating pattern. So what we want to do is we want to implement a fix to this, and it's actually quite simple, right? If we go all the way back up to where we actually create the title. So instead of doing the while 20, how about we just say instead, while not title.include the next word. So if it includes the word that we're actually working on, then we just move on with our lives, right? Because that's what's happening. It says love you ready. So what happens is we see love again. So it's repeating a pattern. So once we see that, we can actually just use this as a heuristic. Now this is not going to guarantee that it will create the best possibility for what we're doing, but it will get rid of the basic concepts or the basic problem. So this is one way of doing it. There are many different others, and I left this as an open-ended part to what you're doing. This is just a simple way of doing it that I found, or that I came up with. So go ahead, and then we can run this, right? So we'll run this on the unique tracks with our new fix in there. Just make sure. Actually, let's run it on the A tracks just to make sure that it works. Let's try love you ready. All right, good. Verified it worked, at least as expected. And then what we'll do is we'll run out unique tracks. And we're going to look at Montana, Bob, and then whatever you got. And then I leave all the questions up to you guys. So Montana, right? We'll run it again. We get a couple different ones. All right, and let's try Bob. I don't know, see if I can get one more in there. There's a whole bunch of different ones for Bob. All right, so anyway, as we see, we did that. I will leave you guys to answer the questions for yourselves. I'm not going to provide any answers to any necessary answers to those. I believe that for the most part, it's quite self-evident. And it'll be interesting to see what you guys come up with. The most common for those, we could run this one more. Let's actually do that. And I will answer 10 in person here. And we run happy, sad. Oh, I have to undo that. That's annoying. Run this one more time so we can actually see what the most common one is. It would be say happy, sad, hey, and little. Right? Let's see. For those ones, it's the you are. Hey is just all hey. So, but it's the you are, right? So, little. Yeah, we did that. All right, so yeah, it's this you are. So bear that in mind for 10. And let's see, 1 through 5 was all done with self-check. And then 14 was explain why these devolve into repeating patterns. Well, obviously, it's because there's repetition. Like there's circular links between different words, right? The word patterns after stop words are removed. Bear that in mind. There aren't as many before the stop words are removed. There are after they are. And then if you try words that I'm going to assume that you guys could find one that terminates in less than 20 words. There's a significant number of different possible answers for that. Describe in 1 or 2 paragraphs how you actually solve that. That's left open to you. Use the starting word Montana, right? We just saw that we got 2 different ones for that. There's a whole bunch of other ones. Bob, which song title do you get? You can get a whole bunch of different ones. And then obviously share your favorite song title that you found. Could be whatever you want. So lots of free points here for you to acquire. So anyway, that's the end of this. The code will be available after Thursday, after my office hours on Thursday, for you guys to peruse and look at. And hopefully by the end of the weekend, you guys should have a grade for this. Enjoy.